Hello, welcome to lab for homework 5, part 1. I'm Brian. I'm going to take you step by step on how to answer these questions. Let's get started. So the first thing that we're going to want to do is get the data and the template. So I am going to save this link as and put it in my homework 5 folder here. It's already King_County Elections 2016. I'm going to save it as a text file. That should be fine. And that'll download. And then I'll do the same thing for this part 5 template. I'm going to save it as a dot. And I'm going to open it. And so here it is in my R instance. I'm going to start by changing the name. And the due date for this, I believe, is Star Wars Day. And I'm going to go ahead and knit to start. Okay, what are we working with? The instructions are questions for you to answer are quoted as blocks of text. Put your code used to address these questions and interpretation below each block. Make sure your answers are not in block quotes like these. Load all libraries you want to use in the setup chunk. When you discover you want to use a library later, add it to the setup chunk at the top. You'll turn in part 1 for the coming week and part 2 for the following week. You will upload the entire template each time with whatever progress you've made. Okay, seems pretty straightforward to me. But then again, I wrote it. Getting the data in. First, we're going to download the data from here. We've already done this. It's a plain text file, about 60 megabytes. Save in the same folder as this template. We've already gone ahead and done that. We're going to read the file into R, and you're going to want to use cache equals true, trunk option that I've talked about before, but I don't think we've had an example to use yet, unless you did. Perhaps it was used in the more difficult homework 4. I can't recall off the top of my head. That's okay. So let's get started doing that. Okay, so the first thing we're going to want to do is load libraries here. Let's see, we're going to use reader. Use library. Flyer. And I think that's it for this first question, huh? So we are just going to go and run those in the case that we need to run things inside the chunks without knitting the document. But so we're going to import our data here. Recall cache equals true. It's already in the option for us, so we don't have to do that. We're just going to say raw and assign it read CSV. And I don't really recall what the name of the document is in total. So I'm going to say WT. So I'm not in the right folder. So I'm going to say set working directory to my source file location so that it will be in our CSSS 508 homework 5 folder. And now I can say stop files and see that this is the file I want to load, and just copy and paste and run that. Looks like we have 643,163 observations of 9 variables. 5 of them are character, precinct, race, counter group, party, and counter type. 4 of them are double, LEG, CC, CG, and sum of count. Cool. And I think that might be it for the first question. It is. Great. So we're going to knit. And one of the cool things about cache equals true is that it will recall that we've already loaded the data the next time that we knit. So typically when you have like a big data set to load, it'll of course take the time to load the data set before you knit the document. But if you say cache equals true, the second time and every time after that, it'll be in the cache. So you don't have to, is it cache or is it cache? Okay, that's not up for a sociologist to decide in this moment. Let's see then, what is our next question? Use glimpse to look at the data, describe the data in their current state. How many rows are there? What variables are there? What kinds of values do they take? Don't list them all if there are many. Are the column types sensible? Okay. So use glimpse to look at the data. Glimpse to run. And this is what our output will look like. Note, I'm just going to show you how to do the R portion. I'm not going to answer the text questions for you in this example. So how many rows are there? What variables are there? I can answer that verbally, but I'm not going to write the text for you here. Rows, 643,163. 9 columns. What kind of values do they take? I already said that earlier. Are the column types sensible? Let's see here. A precinct being a character makes sense. The race for some elections data makes sense to be a character. The counter group, I'm sure that makes sense. Total is a thing. The sum of count makes a lot of sense as a double, meaning it's also like a numeric. These LEG, CC, and CG questions, I'm unsure whether or not these are going to be like tracts or election geographies or something. So if they are, then we should make them characters, but it's not clear to us right now. Okay, in addition to looking generally, look at each variable individually, except consider LEG, CC, and CG at the same time. I will tell you now that these three aren't likely to be useful to you, but maybe guess what they are. I might have already said too much. Remember, these are real administrative data, so they might be really strangely structured. This is common in administrative data for them to have some sort of nuances that if you could do it a different way, you definitely would. Some of the variables are indecipherable. That is, they did not provide you with a really strong code book. In real world data work, you often have to get by with intuition and poking around online with regard to the nature of your data, or poking around the data set and making sense of the variables you understand already. Here's a useful way to look at 10 unique values of a column of individual columns given some data in a variable of interest. So you might want to just say, take some data and then show me the distinct values in that data, in that particular variable, and then show me the first 10 unique values, right? Another thing you may want to do is get a frequency or a count of distinct values using the count function. So let's get started approaching our variables like that. So here we have precinct. Precinct data, if I recall correctly, was a character. So when you have a character, I tend to say I should just get a frequency of how many things are in there. I'm going to say, take the king raw data and then count the precinct variable and then show me the top 10. Okay. Or show me the first 10. Okay, so here we can see that Adair has 237 rows in our data set out of the 643,163. Alderwood, shout out to the big mall. That's where the first Zoomies location is. Has 237 rows in our data set. Race, I recall also being a character. It will say things like voted for the advisory council, that kind of thing. We are going to use King Ra, and then count race, and then we can say something like, I don't know, tail 10, and look at the 10 closest to the bottom in alphabetical order by race. And we'll see things like there are 17,619 rows for US Senator, 30,204 for US President and Vice President. And all the same here, 17,619 for these other races. Cool. Okay. Let's see. LEG, CC, and CG are all double. So maybe what we'll do is say raw, and then select LEG, CG, and then in summary. Let's see, what can we glean from here? My first instinct is looking at this, that all of the numbers in the data are integers, since they have this 0.00 for the minimum and a 0.00 for the maximum and the median. I get the sense that these means are maybe not terribly useful given what else in our data that we have, and that we have some missingness, and just 2 of them is also interesting. Let's see, maybe we could also look at like filter is.na leg, and then look at the first 10. And what do we see here? Looks like the precinct here is the elections office. So maybe the elections office is not within an LEG or a CC, but is within a CG. Perhaps. Let's see if we can glean something from tail. No, it just seems like this elections office precinct is somehow not related, has some bias in the way that it's missing here. But as we recall before, this set of variable probably isn't going to be very useful for us moving forward. Let's look at counter group. Counter group, I seem to recall, was also a character, so I tend to look at count of those things so I can get a frequency of how many values we get. So we're just going to look at the count, and this tells us a lot. It tells us that every value in the counter group column says the word total. 643,163, 64,000 or 643,163. Counter group is useless. Let's move on. Party contains values for political parties involved in each race, so far as we can glean already, looking at the summaries of things, right? So let's look at it in raw, and then we'll count party, and then we'll say sort equals true. And what this will do is order our counts so that the highest are first. So NP like no party, Dem like Democrat, Rep like Republican, Lib like Libertarian, CPN like CPN 2,517 rows. think this is communism, perhaps? And like Green Party? I don't know, but it's probably what we suspect, given the Washington like distribution and Duverger's law. Let's move on to countertype. To inspect countertype, oops, we can say countertype is also a character. We could say king Ra, and then count countertype. 40 is true again. And then let's just look at like the top 10. Okay. So let's see. This column seems to be saying it tells you what a given row was for, but it also has information like times counted and registered voters. It seems like maybe this column has too much information in it, right? Like things that are like write-in or no or yes or approved or rejected are in the same column as like the total of the votes. And so this value might be, we might have to pivot wider here. That there's too many different kinds of sets of values in here is what I get from reading these countertypes. Okay. Let's see. The sum of count was numeric. Let's see that. We could say raw select just sum of count. Okay. And we'll just get a summary since we already saw that one to come in as numeric. Okay. Maybe we should also compare this to data from our other columns. So like king raw selects these things and the race and the counter type. And the counter type was the one that like had too many, perhaps too many types of values in its columns. And sum of count. So what do we see here? See Dare precinct. We see some particular race. We see the maintained or the registered voters. I see. So we can see that times counted here is 485. And this is equal to the sum of count for everything except the registered voters. So it might just be the total number of ballots cast, right? +251 plus 251 is 303 or 302, and 302 plus 183 is 485. And then the registered voters can be some sort of denominator for the amount of votes counted. Okay, that seems pretty useful. Let's move on to our particular quantities of interest. I'll just knit so we can see kind of how things are shaping up so far. I imagine we have a lot of just like little bits of information populating our blocks. I'll see it really big. Okay, so like under precinct, we see like our little quick looks at all of this data. yada, yada. And we have now moved on to this quantities of interest area. We'll focus on only the 3 major executive races in Washington in 2016, president and vice president, the governor, and the lieutenant governor. With these races, we're interested in first the turnout rates for each of these races in each precinct. We will measure turnout as times voted or times votes were counted, including for a candidate, a blank vote, a write-in, or an overvote, divided by the number of registered voters. Differences between precincts in Seattle and precincts everywhere else in King County. Again, these data are not documented, so we'll have to figure out a way to do that. And then the precinct level support for Democratic candidates in King County in 2012 for each contest. Okay, that's a typo. 2016. So I'm just gonna change that real quick, and no one will be the wiser, except for everybody who's like already downloaded this. And that's okay. And we will measure support for the percentage of votes. Typo is now gone. We will measure support as the percentage of votes in the precinct for Democratic candidates out of all votes for candidates or write-ins. Do not include blank votes or overvotes. Overvotes indicate where they selected multiple choices, which again, Duverger's law, am I right? In the overall vote count for the denominator, okay? You will perform most of the data management for number 1 and number 2 in part 1, and part 2 will contain most of the work for number 3. It also covers visualizing the results, okay? So let's see. The goal to accomplish over parts 1 and 2 will be to get the data into 1 row per precinct with the following 7 columns: a precinct identifier, an indicator for whether the precinct is in Seattle or not, precinct size in terms of registered voters, the turnout rate, the percentage of Dem support for president, the percentage of Dem support for governor, and the percentage of Dem support for lieutenant governor. This section below describes steps you may want to do to get your data organized and provide some hints and suggestions for methods, in particular using dplyr and tidier. One thing I will note is you don't have to do these in the way that I've prescribed. Every once in a while, I get to grade a homework that did this, identified 1 row per precinct and had the following 7 columns and did not use these steps. It's a treat, but you know, I don't get to assign grades mostly, so I'm not going to show any bias. So first thing we're going to do is filter down the data. For what we want to do, there are a lot of rows that are not useful. We only want ones pertaining to races for president, governor, and lieutenant governor. So let's trim everything down. You'll want to see how things show up in the data. The easiest way may be to first display every unique value of race and find which ones match our races of interest. Then 2, filter the data to those races. Okay. So let's start. Wait, do we have tidier loaded? Nope. Let's just go ahead and throw that bad boy on here. And scroll that down. Okay. Let's see. A lot of rows that are not useful. Want ones pertaining to races for president, governor, and lieutenant governor. Okay. So let's think about where we would start there. So we could say, take the King raw data and then select just the race column. And then tell me the distinct ones. And then alphabetize them. Right? But that's not going to be a great way for us to grab them and tell where they are. So one thing we might want to do is just like assign this information to an object. And then we could say, as dot character races, find race. And yeah, let's show it over here. Let's see. We're interested in president, governor, and lieutenant governor. Okay. And here, governor is number 7. Lieutenant governor is number 19. US president and vice president is number 34. Okay. So maybe we'll just use those, the elements of this race's data in order to identify the subset. So let's see here. You want to subset it in this part. You want to see things show up in data. The easiest way is to display every unique value of race. We did that. Find which one matches our races of interest, and then filter the data to those races. So, and then I think for some clarity, I'm going to go down here and I'm going to make another code chunk, and I'm going to call that just relevant races. Note the way that I made a code chunk without having to go up here and make one like this or type it is just Control-Alt-I on a Windows machine. But we can find our relevant races in a couple of ways. One way would be to just make a vector like races and subset our races race by saying which positions were they in. It was 7 was our governor, 7, and then lieutenant governor was 19, and then US president and vice president was 34. Try that. So now when we look at rel races, it says governor, lieutenant governor, and US president, vice president. And we could use that to filter our King County relative races data set. So we will assign to the King rel races. Oh goodness, my phone isn't on silent. I'm sorry. King relative races object, the King raw data, and then we will filter race %in% rel races. Okay. So now we've really cut down our data set down to 65,442. And now we could say, just in the console right quick, just to check if it worked, if the King rel races data frame has, let's say we can just count the race column. So we have just our governor, lieutenant governor, and US president and vice president races, and they seem to be about the same or the exact same amount of rows that we saw before. So that's good. I think that we satisfied the conditions of this. Display every unique value of race and find which ones match our races of interest. We did that. And then filter the data to those races. We did that. The next thing is we want to determine which precincts are in Seattle and which are not. You should look at values of the precinct variable and see if you can find it, figure out what uniquely identifies Seattle precincts. Hint, all Seattle tracts have the same naming scheme, but some non-Seattle tracts are similar. So be very careful. You'll then want to create a binary variable that identifies Seattle tracts, for instance, with values Seattle and not Seattle. One approach, you can use the stringer string sub function, which I've shown an example in class before, or the base R substring function to grab a number of characters. A substring from text, say to test if they are equal to something, If you want to use this with if else inside a mutate, you can make a new variable based on the substring of precinct that equals a value. Okay, so let's see where to start. We want to know the precincts. So we probably want to look at the distinct thing that would make Seattle precincts stand out. Okay. So one thing we could do is to say something like, I'm wondering what would be the fastest way to look at this. Part of me just wants to just scroll down. I think I might just do that. It's already in alphabetical order by precinct. So maybe I could just like scroll down here. SEA sounds like Seattle to me, right? I think that's a good place to start. SEA. So let's say we make a new set called King Flag, and we use our King rel races data to get there. Then we make a new column that we'll call, and it's going to be equal to if else substring precincts start equals 1, stop equals 3, equals SEA. So what's going on in this? I'm making a new column called location, and it's equal to a logical expression. So we're going to get back the answers to a logical expression. This logical expression is asking, are the substring from our precinct column that starts on the first character of that substring and ends on the third character of that substring equal to the word, the string SEA? And then we're going to say, comma, if it is equal to SEA, it's in Seattle. And if it's not in Seattle. Okay. And then we could say, King flag, and then count our location. Oops, misspelled that. Count the location. And I don't know enough about Seattle to know whether or not this is the correct distribution of precincts. Maybe I'll just do the same thing again. I'll just go check it out. Maybe I'll do this instead. Maybe I'll just say King flag, and then filter location equals Seattle. Make sure that we got all the ones that we want to capture here. And then we'll just look at that. Okay, so like SEA, we seem pretty comfortable with as an example of what we're talking about. So maybe we should just, instead of looking at it this way, look at the top and bottom for a spot check. Again, SEA looks fine there. Top and bottom. So our precinct has also captured C view. So perhaps Seattle is just SEA and then a space, and we don't want to capture C view. So let's say We go back up here, we say stop equals 4, and we add a space here. Okay. And then we can come back and run the same operation. That looks fine. Yeah, and now the bottom doesn't have C view anymore. Cool. I think we got it. I should probably also show how to do it if you're going to use the stringer version. In order to do that, you could say, well, that would be the same. You could use string detect. We're not to week 8 yet. We don't need to do that. So let's keep moving on. Registered voters and turnout rates. We want to calculate turnout rates as total votes, including normal votes, blank votes, overvotes, write-ins for the presidential race divided by the registered votes. So it'll be something like the turnout is the total votes divided by registered votes. You'll want to look at counter type and sum of count at the same time within each precinct and race. Examine how sum of count values for counter type and values for times counted relate to all the other counter type values. Okay. Let's see here. So we want to look at precinct and race and counter type and sum of count. So let's just start there. Let's start with, and we'll say select our precinct. Select precinct and this and sum of count and counter type. Okay. So let's just like take a look at that. So I'm just going to run this into a glimpse and see what that looks like. Right. And we didn't want the sum over rows. Okay, so we want to add together the normal votes and the blank votes and the overvotes and the write-ins, but we also want to get rid of the ones that are like the times counted and the registered voters things from before, because we know that the times counted and registered voters can't be part of our total votes numerator. We want to add together all the other ones. So we can say filter counter type is not equal to registered voters, since we know that we're trying to collect the numerator of this thing. And if you're sitting at home like, I don't know what numerator you're talking about, I'm going to knit right quick so that you know what numerator I'm talking about. Okay. Here, so turnout equals total votes divided by registered voters. Okay, and so what we're going to do is get these columns of interest and then get rid of the ones that's registered voters, because that's not going to be the information that we want, since that's going to be part of our denominator. And the other thing that we want to get rid of is getting cut off here. But the other thing that we want to get rid of, I'll show you, just like clicking this right quick, is that we want to add together times blank voted, times counted, times overvoted, and write-in. But we don't want to keep, I believe it's times counted, because we want to add together the other ones. We want to add together the times blank voted and the times overvoted and write-ins and the ones for candidates. We do not want the ones that are times counted and registered voters in our numerator. So we'll say filter counter type not equal to registered voters, or counter type not equal to great. So now we can like really build our numerator to get a sense of the voter turnout rates, right? And now we can say by the precincts and the race in order to get our turnout rates at the precinct and race level. And then we'll summarize, we'll call it like votes added up equals the sum of our sum of count column. So let's see what that looks like. This is mad at me for some reason. Okay, it's not mad at me. It's just telling me how it decided to group things together. So now what we have is per precinct and race, the number of votes that were cast in each of the races. And now we can use this to make our turnout rates. So we're just going to call this manual count. And then we're going to take king flag data, and then we're going to select the same things. So we still want the precinct and the race and the sum of count and the counter type. But now we're going to filter, we want the counter type equals the times counted, because that will tell us what's the word? That'll help us build the denominator. So we're going to say filter counter type equals counted. Then we have to change the sum of count to make more sense. So we'll rename the times sum of count to times counted value. Then we'll join back together our numerator information. So left join the manual count, the precinct, and the race. And then we'll make a new thing. That's the difference between the times counted value and the votes added up. And we're taking all of this time to do this in order to make sure that there's so what should we do next? We should then we can pull our difference measure and then do a summary of it. Hold on. I'm confusing myself. Difference equals times counted value minus the votes added up. Give me a second, I'm marinating. Okay. Let's see here. We left joined our manual count for the precinct and race, and then that information. Under, this looks like over here. Starting to question if this didn't go correctly. So let's check that out. Annual count, governor. So we have, for the governor, we have people who voted for Bill Bryant, people who voted for Jay Inslee. The registered voters here is still in the data somehow. Did I misspell registered voters maybe? Let's see here. So we have this. And now let's say I see. I know what I did wrong. This is supposed to be and, because we want the counter type. Yeah, so now when we look at this, I've overcounted. Yeah, so now the only thing that are getting added together are the votes for Jay Inslee, for instance. The times there was no vote, the 0 times that people voted for multiple candidates, the 1 write-in, and the votes for Bill Bryant. Haha. So now, if we run this and then say for our diff column and then do a summary, we'll see that it's all zeros. I see. So in summation, what happened here is we added up together all the things that were not times counted in registered voters, and then we joined it back to a data set that aggregated the times counted information, right? In order to test whether or not times counted was the entire summation of all the other things that wasn't registered voters. And we're able to confirm this by summarizing it here. And since the difference between the times counted value, which was our sum of count for the times counted counter type, and the votes added up, which was our addition from up here, was 0, I feel very confident that these things are the same values. They're counting the same thing. And this means it's really useful for us as we finish out the rest of part 1. So the next thing that we're going to want to do, we should probably also name this. Times counted check. So the next thing that we're going to want to do is turn out rates calculation. Okay. Great. So now we'll take the king flag data and then we'll filter race equals rel races, the third object or the third element in that. So we get just the presidential election. We will filter our counter type to be just the things that we're interested in. So just our numerator and denominator here, which are going to be our registered voters denominator and times counted numerator. Okay, so we filtered to just the presidential races here. And then we've gotten just the columns or just the rows that we want, one being our denominator and the other being our numerator. Yes. And then we'll select the same columns we've kind of been working with, the precinct, the counter type, counter type, count, and most recently the location that tells us whether or not something's in Seattle, right? And then we are going to pivot wider, right, in order to take information that's in cells and turn them into columns. We're going to pivot wider, and our names are going to come from the counter type variable, that is this column or this value registered voters, and this value in the counter type column times counted are now going to become their own columns, and their names are going to be these things, and the values that are going to populate those columns are going to come from the sum of count. Okay, so let's see what that looks like right now. So now what happens is a precinct tells you where it is, or tells you its name. The location tells you whether or not it's in Seattle. Now registered voters is its own column with values of how many people are registered to vote in that precinct. And times counted tells you how many votes were cast in the presidential election in that precinct. And then we want to make a turnout rate. So we'll just say mutate turnout equals times it's like this times counted in our numerator and registered voters in our denominator. So then we can see things like there was 66% turnout here, and that seems like a true. 364 is about 66% of 551. Makes sense to me. And that's it for part one. I know I did it kind of quick, and I kind of got confused here in the middle. That happens to me sometimes. But best of luck to you all. Cheers.